Hello students, I am Dr. Amit Bhatnagar, working as Senior Research Officer in the Department of Agronomy at GB Pant University of Agriculture and Technology, Pantnagar, Uttarakhand. In this lecture, I will tell you about the atmospheric pressure, what is atmospheric pressure and what are the different types of units. There is bar, Pascal, kilopascal, megapascal, torr, millimeter mercury, millimeter of water column, and what are the relationship between these units. Actually, these units relationship is very confusing and asked in examination. So these units should be clear, and what does these unit indicate, it also should be clear. तो ये क्या यूनिट्स होती हैं, क्यों इनमें कन्फ्यूजन है और होता क्या है एटमॉस्फेरिक प्रेशर, आज इसको हम डिस्कस करेंगे. Actually, pressure is force per unit area. In physics science, if we talk about the physics, then pressure is force per unit area. It means force is divided by area, then it is known as pressure. For example, this is area of 1 square meter and we are putting force of 1 Newton. 1 Newton force, we are putting 1 Newton force on 1 square meter area, then force is 1 Newton divided by 1 square meter, that is 1 Newton per square meter. Then force, this pressure is said to be 1 Newton per square meter. It means if we are putting 1 Newton force on how much area? 1 square meter area. 1 square meter area means 1 meter length and 1 meter width. Then it is 1 Newton per square meter. This is SI unit, International Standard Unit, and it is also termed as Pascal and abbreviated as PA. So 1 Pascal is equal to 1 Newton force per unit area. So first this term should be clear. What is Pascal? हमको पता ही नहीं होता पास्कल क्या चीज है. तो पास्कल क्या है? पास्कल इज प्रेशर विच इज एक्सर्टेड बाय 1 न्यूटन फोर्स ऑन 1 स्क्वायर मीटर एरिया. अगर 1 स्क्वायर मीटर एरिया में 1 न्यूटन का फोर्स हम लगाएं तो वो जो प्रेशर क्रिएट होगा उसके ऊपर वो होगा 1 पास्कल. मान लीजिए सपोज द एरिया ऑफ माई palm इज 1 स्क्वायर मीटर. सपोज, हालांकि ये है नहीं, इट इज नॉट लाइक दैट, बट सपोज इट इज 1 square meter and I am putting 1 Newton force on this 1 square meter area, then the pressure on the palm will be 1 Newton per square meter or 1 Pascal. So Pascal is SI unit, International Standard Unit is Pascal. Is it clear? And the other unit of pressure is bar. Okay, and it is generally written as BAR. This bar is related as a barometer which is used for the measurement of atmospheric pressure. So barometer, okay, so it is derived from barometer, and 1 bar is equal to 100 kilopascal. So this Pascal, actually pressure is very large unit, that's why it is expressed in bar. So a bar is very huge unit, okay, 100 kilopascal, or we can write it as if we write it into 0, kilo means 100, kilo means 1000, it is Pascal. Okay, so it means this is 10 to power 5 Pascal. So 1 bar is equal to 10 to power 5 Pascal, or we can say if 10 to power 5 Newton per square meter area. It means if area is 1 square meter and we are putting or we are exerting 10 to power 5 Newton, means 1, 2, 3, 4, 5, 1 lakh Newton. We are putting 1 lakh Newton force on 1 square meter area, then it will face 1 bar pressure. So you can imagine how much large is 1 bar pressure. So bar is a unit of pressure. It is not a unit of force. Don't be confused. Unit of force is Newton. So 10 to power 5 Newton. Ones, tens, thousand, ones, tens, 100,000, 10,000, lakh. 1 lakh Newton force is on 1 square meter. Then the pressure on the body on the surface is 1 bar. So 1 bar is very large unit. Okay, and this is the relationship 100 kilopascal, or we can write it as 1 bar is equal to 10 to power 5 Pascal. If multiplied both side by 10, so 10 bar is equal to 10 to power 6 Pascal, and 10 to power 6 is termed as mega. Mega means 10 to power 6. When we talk about mega, mega means 10 to power 6, and kilo means 10 to power 3. So we can write it as 10 bar is equal to 1, and we can write it as a mega Pascal. M for mega. So this is also a relationship between the unit. So don't be confused. Look it step by step. What is pressure? Pressure is Newton per square meter. 1 Newton per square meter is equal to 1 Pascal. And the other relationship is 1 bar is equal to 100 kilopascal. It is not Pascal, it is kilopascal. So kilo means 1000, okay, 10 to power 5. So other relationship is 10 bar is equal to 1 megapascal. So bar is very large unit, or atmospheric pressure is very high, very large atmospheric pressure. That's why it is expressed in bar. So bar is used for expression of atmospheric pressure, and SI unit is Pascal. Now, what is atmospheric pressure? So the pressure which is exerted by the atmosphere is atmospheric pressure. We can simply say the pressure which is exerted by the atmosphere on our body on the earth surface is atmospheric pressure. Okay, so suppose this is the soil surface, or the surface where we are standing here, tree, human, all the things are here, and this is the atmospheric pressure. Air is there, and the density at the lower surface is high. As the height increases, density decreases. Okay, so we face a pressure by atmosphere on our body. So atmosphere is surrounding my body, and it is this air is exerting the pressure on my body. That is atmospheric pressure. So all the bodies on the earth face atmospheric pressure, and this is atmosphere is gases. Actually this is air, and this is composed of different type of gases. Okay, so these exert a pressure, and this pressure exerted by the atmosphere, okay, is known as atmospheric pressure, and it is termed as 1 atm. Atm is from atmospheric pressure. So we are facing one. So this is the column, this is the height. So this height is maybe in general the height in troposphere is about 20 kilometer, and 85% air is in troposphere. Then the above lying layer is stratosphere, and stratosphere is about 50 kilometer. So and it is contain about 15%. So stratosphere and troposphere, these constitute about 99% atmosphere. So this is, or we can understand it at like as, this is the troposphere. It height is about 20 kilometer. Then stratosphere, height is about 50 kilometer approximate, and then mesosphere, and then thermosphere. And these two, stratosphere and troposphere, constitute about 99% of atmosphere, and we are here, we are living here. So all the bodies are here. So it means it is exerting 99% is here. So it means it is the pressure which is exerted on earth surface, our body and other living bodies, whatever present, जो भी है उसके ऊपर ये अर्थ सरफेस है, इस पे सारा प्रेशर पड़ रहा है. और नो डाउट यहाँ क्या है, एयर का कंसंट्रेशन, एयर डेंसिटी इज मोर एंड एयर डेंसिटी इज वेरी लो, बट इट इज द ओवरऑल pressure which is exerted on the earth surface is atmospheric pressure, and this unit is termed as 1 atmospheric pressure. Now the question is, the unit of pressure, we learned that unit of pressure is Pascal and the large unit is bar. Bar is very large unit. So what is the relationship between the atmosphere and bar? It is very interesting how this relationship is developed. Actually this is gas. These are the gas. Okay, we have to convert this atmospheric pressure, or we have to relate this atmospheric pressure with some liquid pressure, and the liquid used for the atmospheric pressure calculation is mercury. Mercury. If it is a pot and it is filled with the mercury, and we keep a 1 meter tube filled with the mercury, it is already filled with the mercury, okay, and this pot already contained the mercury, and we put this filled 1 meter tube which is filled with the mercury, then this pressure become equal to this pressure. This is science, this is different type of science, and it start to drop. It start to drop, and the height remain. This height, this is the dropping of the mercury into the pot which is already filled with the mercury to adjust the pressure, and it is the dropped, and this drop, okay, now this is the height. This height is 0.76 meter, and this is drop about 0.24 meter. So in narrow tube, mercury dip drop down 0.24 meter, and this pressure here, this pressure is atmospheric pressure. So we can say the atmospheric pressure is equal to the height of this 0.76 मीटर मरकरी. तो ये आपको समझ में आएगा कि हमने एक टेस्ट ट्यूब में, एक नैरो ट्यूब में हमने मरकरी को, पूरा 1 मीटर की ट्यूब थी, उसमें मरकरी को भरा और एक पॉट में हमने उसको रखा, और उसको इस तरह से रखा कि यहाँ से ये ड्रॉप होना शुरू हो. तो जो ये मरकरी जो डाउन होगी, तो जो मरकरी का ये जो प्रेशर होगा एटमॉस्फेरिक प्रेशर के बराबर होगा, यहाँ तक ये डाउन होगा. तो इसका मतलब ये जो कॉलम है ये किसके बराबर प्रेशर एक्सर्ट करेगा? एटमॉस्फेरिक प्रेशर के. सो दैट्स वाई 0.76 meter, it means 760 millimeter height of mercury column is equal to 760 millimeter mercury equal to 1 atmospheric pressure. तो ये रिलेशनशिप हमको पता चाहिए. व्हाट इज द रिलेशनशिप? सो इट इज कन्वर्टेड, दिस मर्करी कॉलम pressure is converted into atmospheric pressure. So ये जो mercury column होगा, that is equal to 1 atmospheric pressure. Now other interesting calculation is that this is in liquid and this is in gas. 1 atmospheric pressure is exerted by the gas and this is liquid. Okay, so it is exerted by gas and this is exerted by liquid. So we have to convert this pressure into Pascal and other unit. So for a liquid pressure formula, okay, suppose it is a container and it is filled with the, or we can say it is the mercury. We are taking the example of mercury, and mercury is 760 millimeter. It is filled with the mercury. So the pressure is exerted on the bottom. Now the pressure is exerted on this bottom. So pressure is here on the bottom. So now what is the weight of this mercury? This weight means this force is exerted on this bottom, and this is actual the pressure. And in such case where liquid exert the pressure, then formula of pressure P is equal to what is the height, what is the density of liquid, and the G is acceleration due to gravity. This is the formula. It means the pressure at the bottom is H into D into G. So the height 760 mm mercury जो बॉटम पे जो प्रेशर लगा रहा है वही प्रेशर एक एटमॉस्फेरिक प्रेशर के बराबर है. अब लिक्विड का जो प्रेशर निकालने का फॉर्मूला होता है दैट इज ये होता है. किसी सरफेस पे निकालने का क्या होता है? फोर्स अपॉन एरिया. फोर्स अपॉन एरिया. एक्चुअली दिस फॉर्मूला इज डिराइव्ड फ्रॉम दिस फॉर्मूला. बेसिक फॉर्मूला इज फोर्स अपॉन एरिया और ये जो फॉर्मूला निकला है इसी से डिराइव होकर निकला है. सो डोंट बी कंफ्यूज्ड. Basic formula is force upon area, and for liquid it is derived in the form of what is the height, what is the density of the liquid, and G. Here H is now we use SI standard unit. So 760 mm. So we have to write it into meter. So 0.76. Now the density of the mercury. Density of mercury is 13.59. Approximate 595 into 10 to power 3 kilogram per cubic meter. Here it is meter. It is kilogram per cubic meter. We have to use SI unit, international standard units, means meter kilogram. Okay, and then the G is 9.806 meter per square second. Okay, so if we multiply this whole the number, then it is 101,325 Newton per square meter. Because it is in meter, kilogram and second, so the unit is in conversion is in Newton per square meter. It means 76 mercury pressure is equal to 1 Newton per square meter, or we can write it as 1 atmospheric pressure because it is equal to 1 atmospheric pressure. So 1 atmospheric pressure is equal to 101,325. We write it as a Pascal because 1 Newton per square meter is equal to 1 Pascal. Then we can write it as 101.325 kilopascal. Okay, and we can write it as 1.01325 bar because 1 bar is equal to 100 kilopascal. So it is kilopascal. We divide it by 1000, then 101.325 kilopascal, then divide it by 100 to convert into bar. So this is the relationship. 1 atmosphere is equal to, this is the value, and actually this is 0.76 millimeter mercury. Okay, if suppose mercury is not used and water is used, suppose we are using here water, not the mercury, then height will be more because density of water is 1000 kilogram per cubic meter and density of mercury is about 13.595 kilogram per cubic meter. Okay, so 1 cubic meter mercury exert this kilogram weight and 1 cubic meter into 1000. So it means mercury is about 13.6 times. It is approximate 13.6. So it means mercury is 13.6 heavier than water. So it means तो यदि हम इसको water भरेंगे तो it means its length will increase to exert the same pressure. This is the reason that the water column length is more compared to mercury, क्योंकि mercury का जो एक क्यूबिक का जो weight है वो 13.6 into 1000 है, while in case of water it is only 1000 kilogram. Okay, तो अब हमें इसे water का निकालना हो तो हम कैसे निकाल सकते हैं? P is equal to H into D into G. Okay, pressure is this one 101,325 Pascal, we have to find height of water. Our interest is in water height. Density we know 1000 and G is 9.806. Then H is approximate 10.33 meter, or H is equal to 1033 centimeter. So 1 atmospheric pressure equal to 1033 centimeter water. It is 0.76 meter mercury, not millimeter. Millimeter is meter. Okay, so 1033 सेंटीमीटर, और मिलीमीटर कितना हो जाएगा 103.3. इसे 10 से डिवाइड कर देंगे तो मिलीमीटर. सो दिस इज द रिलेशनशिप दैट 1033 centimeter water equal to 1 atmospheric pressure. But in case of bar, if we convert into bar, actually 1 atmosphere is equal to 10.01325 bar. So that's why for bar this height is different. So for 1 bar it is about 1019 centimeter. इसको हम रख के देख लेंगे, इससे डिवाइड कर दीजिए इसको. So 103. इसको हम ऐसे कर सकते हैं. ये कैसे आया 1019 सेंटीमीटर? एक्चुअली 1 atmospheric pressure is equal to 1033 centimeter water is equal to 1.101325 bar, and we want to relationship between these two. So 1 bar is equal to 1033 divided by 1.101325 is equal to 1019 centimeter. So it is confusing in generally examination in asked what is the height of water. If it is asked for the atmosphere, so 1 atmosphere is equal to 1033 centimeter water, and but for bar it is 1019 centimeter. So remember it. So both are different, and 1 atmosphere approximate to 1 bar. 1 atmosphere approximate 1 bar, actually it is 1.101325. So it means we are facing 1 atmospheric pressure or 1 bar pressure. तो हमारे ऊपर जो प्रेशर लग रहा है वो 1 बार का प्रेशर है, और ये बहुत बड़ा प्रेशर है. 10⁵ न्यूटन फोर्स पर स्क्वायर मीटर एरिया का फोर्स वी आर फेसिंग. 10⁵ न्यूटन. इट इज वेरी वेरी लार्ज फोर्स. 10⁵ न्यूटन per square meter. So these are the relationship between the different units. And the other unit of this atmospheric pressure is torr. And it is actually torr is related with the Torricelli who worked on the atmospheric pressure. So 1 torr is equal to 1 millimeter mercury. So this is the general relationship. 1 millimeter mercury is equal to 1 torr. So this is the in general relationship. So we learned that 1 atmospheric pressure is equal to 101325, 1,01,325 Pascal, and it is about 1.01325 bar, or 1, and we can expressed in the form of water column. In case of water column it is 1033 centimeter, and in case of mercury it is 0.76 meter or 760 millimeter. And this millimeter mercury, actually we are using 760 millimeter mercury, so we can write it as 760 torr. So as the atmospheric pressure is also expressed in millimeter mercury. Suppose atmospheric pressure is 700 millimeter mercury in an area. This pressure is affected by many factors. Atmospheric pressure is affected by various factors. Suppose at a place it is 750 millimeter, so we can write it as 750 torr. So this is the simple calculation. Simple in the sense that it is linked step by step. So we should have clear idea about what is pressure. what is liquid pressure? Why we are using the mercury? 760 millimeter mercury pressure, what does indicate? So this indication is in the sense of pressure. P is equal to, by the formula of H into D into G, and then it is equal to 1 atmosphere. Then there is conversion, Pascal and bar. So it was about the atmospheric pressure. What is atmospheric pressure? And this atmospheric pressure is affected by the G value, because formula is P is equal to H into D into G. Then density of mercury may be affected by the temperature. So there are several factors which affect the atmospheric pressure. So that's why we consider 1 atmospheric pressure or approximate 1 bar. Actually, it is not 1 bar, it is 1.01325 bar. So this was about the atmospheric pressure and their units. Thank you very much.